All right, let's take a look at another tool that I can use with triangles, and it's called the law of sines. In this section, we want to use the law of sines to solve an oblique triangle, and then maybe try some problem solving with that as well. We use the law of sines, like I said, when I have an oblique triangle. In other words, a triangle that doesn't have a 90-degree angle in it. So if there's no 90-degree angle, I cannot use my normal trig ratios, nor can I use Pythagoras. We sort of use derivations of the two, but I cannot use these tools as I did in a right triangle. However, there's another law that I can use. There's actually two laws. In this section, we'll look at the law of sines. In the next Scribblecast, we'll look at the law of cosines. So the law of sines is a nice simple law, and it just relates a side and its angle. And it says that if I take any side and divide it by its angle, that will be equal to any other side divided by its angle. And when you use this law of sines here, you always only just use two parts of it. So I might use the A and the B part, or I might use the B and the C part, or I might use the A and the C part. So here's a question. Let's see how it looks when we're working with it. They say in triangle ABC, side A is 4.56, angle A is 43 degrees, and angle C is 57 degrees. And the question is, solve the triangle. In other words, that what they want me to do is to find out all the sides, all the angles. When they say those words, solve the triangle, it means tell me everything about that triangle. And what I like to do often with those is write them down. So I'm going to write A is equal to, B is equal to, C is equal to, angle A is equal to, angle B is equal to, angle C is equal to. And then fill in the stuff that I know. A I know is 4.56. Angle A is 43 degrees. Angle C is 57 degrees. So that's a piece of information that I know. One thing that I could figure out right away is what this other angle is, because I know that all three angles of a triangle have to add up to 180. So I just have to subtract these two from 180. It looks like that comes out to 100 if you add those together, and so B has to be 80 degrees. So I figured that one out. Now I need to figure out what B and C are, and here's where the law of sines comes in. I know A, let's figure out B. So the two ratios that I'm going to use are A and B. So I'll say A over sine A is equal to B over sine B. And now I'll plug in the information that I know. So A is 4.56 over the sine of A, which is 43 degrees, is equal to B, I don't know, divided by sine of angle B I figured out was 80 degrees. Okay, so now I just have to plug these in my calculator, use my normal multiplication or cross multiply divide thing. I like to do the cross multiply divide, so I write B is equal to 4.56 multiplied by the sine of 80, all divided by the sine of 43 degrees. Let me pull out my trusty calculator and figure out what that is. Okay, is it going to work? Yes. So 4.56 multiplied by the sine of 80, divided by the sine of 43 equals, I forgot a bracket, equals 6.58. Let's call it 6.6. We'll round to one decimal place. So 6.6 meters, feet, whatever the unit is. So I'm going to go back up here on B and write my 6.6. So the only thing I'm missing is C. So let's do C right here beside. So since I'm looking for C, I have to always use two of these. Let's use A and C. I'm using A just in case I got B wrong for some crazy reason. I'm going to use A, those numbers I know from the question, and I'll use C. Okay, so A over sine A is equal to C over sine C. A is 4.56. Sine of A is 43 degrees. C I don't know. And sine of C is 57 degrees. Again, cross multiply divide. I'll get 4.56 times the sine of 57 degrees, all divided by the sine of 43 degrees. Okay, enter the calculator. 4.56 times the sine of 57 divided by the sine of 43. Sine of 43. Remember my bracket? I come out to 5.6. So side C is 5.6. And now I've solved that triangle. And really that's the whole thing of solving an oblique triangle, is using this law of sines. And I can use this one when I know, as I say up here, when I know an angle and its side. So A and angle A, or B and angle B. If I know those two, I can solve the triangle. Here's just a quick little application of doing that. I've got a building that I don't know how high it is, and that's probably what I'm going to be looking for, or part of that. And it says at a distance of 100 feet away from the building, an observer notices that the angle, this whole angle here, is 41 degrees. That'll take you to the top of the building. And then they also notice that a poster is there, and the angle to get up to that poster is 21 degrees. And then the question says, how far is this poster from the roof of the building? Well, that looks like an interesting question. I have, in this triangle here, I guess I would know this angle right there. I would know this angle here, because the whole angle's 41. If this part's 21, that angle must be 20 degrees. But I don't know any other information about this triangle. Well, maybe I know another angle. Let me think about that. If this angle's 21 and this is a 90, it forces this angle here to be whatever 180 minus 90 minus 21 is. I think that's 69 degrees. And since this angle here, this whole angle is 180 degrees, so this angle up here must be 180 minus 69. 180 minus 69 would be 111. Gee, I'm on a roll here. Okay, so that's 111 degrees, and since this is 20, together that's 130, 131. So this angle here has to be the difference of 180 minus 131, which I think is about 49 degrees. Okay, so just doing a little bit of trickery there, a little bit of geometry, I've figured out all of the angles of my triangle here. And really what I'm looking for is this distance, the green distance right from there to there. I guess it's red now. I want to know this distance. So I have three angles, but I don't have a side on this triangle. They do tell me that this side is 100, but that's not in this triangle up here, so I can't really use it. However, I do have a 90 down here. And if this triangle here is a 90, all those sine, cos, and tan are in. And so let's figure out what this side is right here. This side would be the hypotenuse of this triangle. So of this small one, this would be the hypotenuse. If this is the angle in question, this is the adjacent side. So I'm going to use cosine. Cosine of an angle is equal to the adjacent side divided by the hypotenuse. So the cos of 21 degrees is equal to the adjacent side, 100, divided by the hypotenuse, which I don't know. I'll just maybe label it HYP. Now to solve for that, I'll cross multiply, divide. So by hypotenuse is equal to 100 divided by the cos of 21 degrees. Let me try that on my machine. 100 divided by the cos 21. Well, 107.114. So the hypotenuse is equal to 107.114. Let's just call it 0.1. That's this distance here. Let me put that in black. 107.1. Now I've got a triangle up here in which I know a side and I know all the angles. So if I know a side and its angle, I can use the law of sines to solve that. Okay, so let's call this side A, and let's call this angle A. So I'd have 107.1 divided by the sine of 49 degrees is equal to B. Doesn't matter which one I guess it does matter. I want to know this distance. Let's call that B. So this is side B and this is angle B. So side B I don't know, but the sine angle B I know is equal to 20 degrees. Okay, again, with this one, B is equal to 107.1 times the sine of 20 degrees divided by the sine of 49 degrees. Hopefully you're comfortable with dealing with proportions like that and solve that. We're at this point, might as well solve it. 107.1 times the sine of 20 divided by the sine of 49. I come out to 48. 48. So does it say feet or meters or what? 100 feet. So that was 100 feet. So this would be about 48 feet. The bottom of that poster would be from the top of the building. Okay, that's sort of an involved question, but it's a good one. All right, last concept in the law of sines deals with something that is a little bit funny with particular information given about the law of, about a triangle. Specifically, we call this the ambiguous case. And it's the case in which all of these following conditions apply. And if they apply, then I may have two answers for the angle. I guess I shouldn't say may have, I will have two answers for the angle. So if here's my triangle A, B, C. Here's my sides A, B. I forgot to put a little letter C in there. I'll put that right there. So that says the only information known is angle A, so I know this, and the sides A and side B. So that's the three pieces of information I know. So I know this angle and its side, and I know one of the other sides. And another piece of information that has to happen is that the angle A must be acute, and side A, this one, has to be shorter than side B. Okay? And then side A has to be longer than the altitude. This sounds like a funny requirement. The altitude of a right angled triangle where C is the right angle. Here would be the right angle, and the hypotenuse is B. That's sort of a funny one. Anyway, if I come up with a question where all of these characteristics apply, then to solve for that, to solve for the angle, the book has us look through two formulas. The formulas look a little bit ugly, but they help. They're basically doing the same thing that we did with the law of sines. It's just that they're accounting for two different options. So let's look at one where this might happen. Okay, so I have a triangle that has side lengths of 20 and 11. The angle opposite the latter side, that's 11. The angle opposite the 11 is 29. This is 29. The question says, what is the measure of the angle opposite the side has a length of 20? So they want to know what this angle is over there. Well, this one counts for an ambiguous case. because I know a side and its angle, and I know this other side. Also, this side is shorter than this one, and I've gone in and made sure that the height restriction is also in there. So it is an ambiguous case. So to solve this, I simply plug these numbers into my formula. So this angle, we'll call this angle B, this would be A, this would be C. So this is side B, this is side C, and this is side A. I guess I don't need any C's. So angle B is equal to the arc sine, remember we said that you can write that like this too, of B, so B is 20, multiplied by the sine of A, which is 29, divided by A, which is 11. Let me do that on my machine. So I have to do the arc sine of 20 times that by the sine of 29. Okay, sine of 29, and divide that by 11. Uh-oh, I got an error. Where did I mess up? Just a second. Domain error. Let me try it again. Okay, so arc sine of, oh, hold it. Oh, no. I've written this down wrong. Sorry, I wrote that down wrong. It's the arc sine of this whole thing. So it's arc sine of B, which is 20, times by the sine of 29, divided by A, which is 11. There. Okay, brackets, that was my problem there. Okay, so I go arc sine of, in brackets, I'll go 20 times the sine of 29 divided by 11 equals, uh-oh, and I come out to, oh, a number that looks a little bit funny. Oh, I didn't do arc sine. Ah, calculator troubles. Let me try it again. Okay, arc sine, yep, of 20 times the sine of 29 divided by 11, close my bracket, and hit go, and there it is. All right, so B is equal to, angle B is equal to 61.8. 61.8 degrees. Now that is one of the angles. That's if this side 11 was coming in this way. But if the side 11 swung out that way, which it could, then I need to also figure out what, oh no, that's, I said that wrong. This is the angle that's 61.8 degrees. And now if it's swung in this way, I need to figure out what that angle is. And I do that simply by taking B, it could also be 180 minus whatever I got from that top thing, 61.8. So 180 minus 61.8 would be 118.2 degrees. That would be that angle. So that's the ambiguous case when it comes to the law of sines. It's fairly tricky to identify which are the ambiguous case and which aren't. And you really need to sort of practice quite a few of those ambiguous cases in order to recognize them. Again, take a look through the video again. Hopefully the instructions will help you. And also take a look through your textbook too. Try some questions, and if you have any troubles, give us a holler.